Security alert. Axios, the most popular HTTP client on NPM, with 83 million weekly downloads, has been compromised. Malicious versions 1.14.1 and 0.30.4 drop a cross-platform remote access Trojan that targets macOS, Windows, and Linux. If you use Axios in any project, you need to check right now. On March 30th, 2026, an attacker compromised the NPM account of Jason Simon, the primary maintainer of the Axios project. They obtained a long-lived classic NPM access token and changed the account's email to an attacker-controlled Proton Mail address. Using this access, they published two malicious versions of Axios, 1.14.1 on the current branch and 0.30.4 on the legacy branch. Both versions inject a new dependency called plain-crypto.js at version 4.2.1. This dependency is never imported anywhere in the Axios source code. Its sole purpose is to execute a post-install script that drops a remote access Trojan on your machine. The malicious versions were live on NPM for approximately 2 to 3 hours before NPM removed them. But in that window, anyone whose CI/CD pipeline, developer environment, or build system pulled a fresh install could have been compromised. Here's exactly how to check. Run npm list axios and look for version 1.14.1 or 0.30.4. If you see either, you are affected. Also check your package lock.json with GRET. But here's the critical part. Even if you don't see those versions now, check for the presence of the plain crypto.js directory in your node modules. If that directory exists, the dropper already ran. The anti-forensics in this attack are sophisticated. After execution, the malware deletes setup.js, replaces the package.json with a clean stub that reports version 4.2.0 instead of 4.2.1. So running npm list after infection shows plain crypto.js at 4.2.0, deliberately misdirecting investigators looking for 4.2.1. If you find the directory at all, assume compromise. Next, check for the RAT artifacts on your system. On macOS, look for a file at library caches ashicom.apple.act.mond. It's disguised as an Apple system cache file. On Windows, check for wt.exe in your program data directory. It's actually a copy of PowerShell disguised as Windows Terminal. On Linux, check for e.tmp and ld.py. If any of these exist, your machine has been actively compromised. This is one of the most operationally sophisticated supply chain attacks ever documented against a top 10 NPM package. The attacker didn't rush. They planned every step. They pre-staged the attack across a full 18-hour window. First, they published a clean version of plain crypto.js at 4.2.0, a harmless decoy that establishes legitimate publishing history and avoids triggering brand new package alerts from security scanners. The 56 cryptographic source files inside it are bit-identical copies from the real crypto.js library. Everything looks normal. 18 hours later, they published version 4.2.1 with just one addition, a post-install hook that runs setup.js. That's the trigger. Then within 39 minutes, both the current and legacy Axios branches were poisoned with the new dependency. Here's what makes this especially dangerous. The legitimate Axios project uses GitHub Actions, with NPM's OIDC trusted publisher mechanism for verified releases. The malicious versions bypass this entirely. They were published directly via the stolen classic access token. That's the first red flag automated systems should catch. A release that doesn't come through the expected CI/CD pipeline. The post-install script is obfuscated with XOR cipher, using the key order 7077 and a base 64 layer. When decoded, it contacts the C2 server at sfrclac.com on port 8000 with campaign ID 6202033. It delivers platform-specific payloads. On macOS, it downloads an Apple script dropper to RTMP, fetches the RAT binary to library caches .com.apple.act.mond, and executes it via ZSH. On Windows, it copies PowerShell to program data as wt.exe, writes a VB script launcher to temp, and executes with hidden window and execution policy bypass. On Linux, it curls a Python script to -tmp ld.py and runs it as a daemon with no hup. The entire payload executes within 2 seconds of npm install beginning. The C2 is contacted before npm has even finished resolving the rest of your dependencies. After execution, the dropper self-destructs. It deletes setup.js, deletes the malicious package.json, and replaces it with a pre-staged clean stub. Running npm list afterward shows nothing suspicious. Block these immediately. The C2 domain is sfrclac.com at IP 142.111.206.73 on port 8000. The post body sent to the C2 identify your operating system. Packages.npm org product 0 for macOS, product 1 for Windows, product 2 for Linux. On your file system, check for the macOS RAT at Loda's library caches .com.apple.act.mond, the Windows PowerShell copy at programdata.swtal.exe, and the Linux Python dropper at tmp ld.pim. The attacker accounts involved are Jason Saman, the compromised legitimate account, and Nerwise, an attacker-created account. Both used Proton mail addresses. Add the C2 domain and IP to your block lists now. If you run a firewall, drop all traffic to 142.11.206.73. Add sfrclac.com to your hosts file, pointing to 0.0.0.0. If you are affected, here's your full recovery playbook. Follow every step. Step 1. Downgrade to a safe version immediately. Use axios at 1.14.0 or 0.30.3. Pin it exactly in your package.json using both overrides and resolutions fields to prevent any transitive dependency from pulling the malicious version back in. Step 2. Remove the malicious dependency. Delete the entire plain crypto.js directory from node modules, and reinstall with the ignore scripts flag to prevent any remaining hooks from executing. Step 3. If you found any RAT artifacts on your system, the macOS binary, the Windows PowerShell copy, or the Linux Python script, do not attempt in-place cleanup. You must assume full system compromise. Wipe and rebuild from a known good state. There is no safe way to clean a machine with an active RAT. Step 4. Rotate every single credential that was accessible at install time. That means your npm tokens, your AWS access keys, your SSH private keys, cloud credentials for GCP and Azure, all CI/CD secrets and pipeline tokens, and every value stored in your .env files. Assume the attacker has all of them. Step 5. Audit your CI/CD logs thoroughly. Review every pipeline run that executed npm install during the 2 to 3 hour window the malicious versions were live on the registry. Step 6. Block the C2 at your network perimeter right now. Add firewall rules to drop all outbound traffic to 142.206.73 and add sfrclac.com to your DNS block list or hosts file. This is not optional. If the RAT successfully executed, the attacker already has your credentials and is actively using them. This attack highlights 3 critical practices every team should adopt. First, use npm sci with the ignore scripts flag in CI/CD pipelines. Post-install scripts are the attack vector here. Blocking them prevents the dropper from executing even if a malicious dependency gets pulled. Second, enable npm's trusted publisher mechanism with OIDC for your own packages. The legitimate Axios releases use GitHub Actions with cryptographic verification. The attacker bypassed this with a classic access token. If your project publishes to npm, switch to OIDC publishing and revoke any long-lived tokens. Third, use tools like Socket, Snike, or Step Security Harden Runner that monitor for suspicious dependencies. Socket flagged plain crypto.js within 6 minutes of publication. A dependency that appears in the manifest but has 0 usage in the codebase is a high-confidence indicator of a compromised release. Watch for it. Check your projects now. Share this with your team. Subscribe to Prism Labs for security advisories and developer content. Stay safe out there.